precision full wave rectifier. Aim to design and verify a precision full wave rectifier and determine its performance characteristics. Now let us consider the input current I1 as 50 microamperes when we use 741C op-amp. Then R1 input current resistor will be equal to Vi by I1, and Vi is also considered as 0.5 Vp. So 0.5 volts by 50 microamps will give us 1 kilo ohm standard value. R2 will be considered as 2 times R1 for amplification. This is the feedback given in the A1 or the first op-amp, and R3 will be equal to parallel of the two because that is equivalent to a minimizing resistance, and it is found to be equal to 680 ohms standard value. Then for the second set, let us consider R4 equal to R5 equal to R1, so let it be equal to 1 kilo ohm. Then R1 by RF is equal to V0 by Vi, or so R1 by RF is equal to V0 by Vi, or we can hence calculate the value of RF. Okay, and RF is found to be equal to 4K by 1K into 0.5, giving you 2 times Vp. The value of it's a theoretical value. Next, the resistor R6, which is the R6 is the feedback resistor. It is equal to 4 times R4, that is 4 times 1K and equal to 4K. And R7, the minimizing resistor for the second op-amp, is equal to parallel of R4, R5 and R6 equal to 470 ohms as a standard value. The design. We have A1 the first op-amp and A2 the second op-amp. We have 2 diodes here. The diode values we are generally considering the standard ones. So input is given to the inverting input resistor. The V1 is connected here, and R1 the input resistance is connected. Now we have a feedback from the 6th terminal of the op-amp through the diode and another RF value, and thirdly from the total circuit we have got here, which is the feedback before connecting to the second op-amp. This is the minimizing resistor connected to the non-inverting terminal. The parallel of these equal to 680 ohm standard. You can see the diodes are connected in the feedback and the output, and their direction is the same. Here we have connected this resistor is a connector towards the second op-amp, and this is the input resistance to this, and this is the feedback resistor. You have taken amplification as 4 times here, so therefore it is 4K. The parallel of these two parallel is taken here, and that is found to be equal to 470 K, parallel of the 3. This is the second op-amp through which we are getting the final output of the precision. Here we are going to initially take the 2 outputs from here and sum them up to give you the final value. One is taken for the positive and the other is taken for the negative output, and we are giving it here and summing it up. You can see this is the input that is given to the inverting input terminal, and this is the output, the fully rectified waveform that we are going to get. Procedure. Rig up the circuit as per the circuit diagram. Switch on the digital trainer kit, the AC input supply, that is signal generator, and the CRO whose probes are tested. Then switch on and measure the output voltage and compare it with the theoretical value. Observe the waveform to compare with the practical and the theoretical value. Bring back the signal generator to 0 position, switch off the digital trainer kit and the CRO. For the circuit, from the input source we have got the supply, this is ground and this is the input source through R1 resistor, and from the other end of the R1 resistor it is connected to the output terminal here, that is 6. Then we have got another end of it that is connected to the junction. You can see from the junction it is connected to terminal 2 minus the minus or the inverting input terminal. From 3 it is brought to here, the junction which is also connected to the 680 ohm resistor, and the other end is brought to the ground. We can also see the junction after this. This is the feedback resistor that is connected. The feedback resistor is across -2 and it is across the 6 junction. You can see this is diode D1 and D2. D1 is across 6 and the 2 and 6. D1 is across 2 and 6, whereas D2 is across 6 and the junction of the resistor, that is which is also going to the other op amp. From the other end we have got this as R6, which is R5, which is going to R6, which is again connected to, this is connected to the CR. This is connected to the switch off. Now, and from the first op amp we have from 4 to -12, from 7 to +12, and ground is taken here to this junction, and again ground is taken here. Now for the second op amp, you can see from -2 of the second op amp it is connected to the junction of the diodes. From 3 it is connected to this junction, which is connected to 480 ohms, the decayed resistance box set at 470 ohms. Then we have 6 of the second output coming to the the feedback circuit that we have got. Then 4 of the second op amp is connected to -12. 7 of the second op amp is connected to +12. Ground is connected to ground here. Now we have switched on the digital trainer kit and the supply, and we will switch on the CRO. You can see the input supply and the rectified signal. The rectified signal has got a bit of damping due to experimental errors, and therefore you cannot see the two. Okay. Now we have to switch off the circuit as in the reverse direction as we have done. So we have switched off the CRO, then the signal generator and the digital trainer kit. Off.